Hi, I'm Professor Chaos. Yeah, let me tell you what, the Earth is not fucking flat, you dipshit.
Yeah, baby, give me brain. Yeah, baby, go insane. Yeah, let me switch lanes. Yeah, go a different pace. Man, I'm on a plane. Yeah, man, I can't complain. Yo, first class game. Yeah, too much money game. Bought a new chain. Yeah, ignorant ways. Yeah, ignorance of bliss. Yeah, smile on my face. Yeah, mama just pray. Yeah, grandma just pray. Yeah, grandma want a car. Yeah, wanna switch lanes.
Okay, so I had to restart this video like twice because again, I'm trying to figure out the right words. But yeah, we're gonna be talking about geometric constructs, and I know this guy's like, oh my god, it's a math lesson. Oh, but no, it's actually supposed to break down the fundamental physics of why the fucking flat earthers are completely fundamentally wrong, and also about, again, how actual geometric shapes work, why we learn this stuff. So, let's get started.
If you don't open it, how we gon' keep eating? Had to grab my five, so step inside. When I came around that corner, that boy almost cried. Now I ain't something I had to play, yeah. I ain't tryna stack up his cake, yeah. Baby, honey, baby, that's my kind of date, yeah. Ex wanna love me, but it's too late now. Sorry, little mama, I cannot save ya. Once I did, try to change ya. You try to shoot me in the how it laser.
So, first we're gonna have to get into the first subject of this geometric plane, which would have to be the fixed point, meaning that it's the zero dimension, meaning that there's no dimensions of distance, time, volume, or anything. There's nothing. So, what that would look like, which I could probably just show you with hand gestures because that's just how I fucking roll. Fuck you, I like that. But yeah. So basically, that would have to be a point. So imagine, right? Take to imagine. You have to use your brains. Just think about it, right? A point. There's no direction. You look here. See? Look at my fingers. Right here. Where am I going? There's no point of where it's going. There's no distance. There's no destination. There's no anything. It's just a fixed point, right? It's a fixed point, meaning there's no direction. There's no distance. There's no like ability to go anywhere. Because that's just fundamentally how that shape is. It's not a shape. It's not distance. It's not a dimension. It's something that is fundamentally flawed and skewed, meaning that you can't move anywhere. It is a fixed point. It just says you are there and you are going to stay there, meaning there's no line or anything like that. Now, let's get into the first dimension, shall we?
Hello? Shatter pixels on the screen. A digital ghost in the machine. Every whisper turns to static.
And now we're going to be talking about the first dimension. Here's where things get interesting. Notice how I was talking before when we were talking about, you know, the distance? This is what this first dimension is called. This is called the distance plane. At least I was called the distance plane because I'm fucking cool like that. Fuck off. But yeah, that would be considered the distance. Now, it's gonna be a little bit tricky. So when you have a point, which is a zero dimension, as we discussed before, notice how I said that there's no distance, there's no time, there's nothing. So, how do we fix that? There's a point here and a point here. You can make a line. Therefore, that is a distance from point A to point B. Meaning that those have to have a dimensional plane, even if it's just one line. You can't go back and forth. It's just point A to point B, one way. Right? That is how that first dimension is. You just go from point A to point B, one way. It's not even a shape, it's a line. It's distance. That's how we measure distance in geometry. That's how we go from graphs to actual geometrical planes. Now, let me explain the second dimension.
Does it feel empty? Can somebody please just tell me? I'm so sick of all the trying. Feels like part of me is dying. I bet you never really seen me. Just a filtered happy dream. I'm probably getting another notification.
So the second dimension, as we had to explain before, basically, if you take, we have to recap this, but the the, the zero dimension or the point dimension is just one right here. It's a fixed point. The first dimension is point A to point B, meaning that it's distance. It's from point A to point B. Simple. The second dimension, which, by the way, when you learn about dimensions, you learn about how shapes work. When you realize that even a piece of paper technically is a 3D object by molecular structure, it goes up, it goes there, even though it's so thin that it looks flat. It's not. It's nowhere near flat. Like, when you take this knife right here, it looks flat, like, it looks flat. When you look into it, you can tell that it still has its dimension. It still has its 3D dimension. That is why we can't touch a 2D object, because it's only visible by the eyes, meaning that you can't touch it. You can't touch a 2D dimensional object. It's like trying to touch letters. You can't do that without it being a 3D object. So, to explain what a 2D object is, after recapping all that, a 2D object, the only directions it can go in is up, down, left, and right. Now notice how I did that pattern. Up, down, left, right. That is basically an X and Y axis graph. That's not the full initial thing. I'm fucking tired. I'm allowed to think like this. But if you notice how there's a negative X, an X axis, a Y, and a negative Y axis. Those, you're only moving up, down, left, right. There's no way to go back and forth. Like this, we don't have that in a 2D shape. Because again, we can see it, but we can't touch it. It's like touching a flat screen. It's like touching a cartoon. Like, you see this, right? It's my wallet. Now, granted, I can hold a 3D object of him, but you can't hold. Like, it's like taking this right here and trying to grab it. You can't, because it's a 2D object. Meaning you can only see it. You only see it. You can't grab it. You can't hold it, because it doesn't have the depth and volume like a 3D object. And not only that, but a 2D object typically would be like a square or a circle or a triangle or something that has angles. You know what I mean? Something you can measure with angles and has basic symmetry. But the thing is that with a 2D object, sure, you can imagine it to be literally anything, but it doesn't have depth, it doesn't have weight, it doesn't have anything like that. Therefore, it is a 2D object that you can only see through your eyes and touch nothing else. So, when you try to grab that object, you can't, right? And the thing is, that shape, which I'm gonna use a square for example, because why the fuck not? We just did that recap for the whole entire thing. But that would be this, 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 and this. Notice how that is a square, right? And the only way you can move that square, the only way you can move that fucking square on a 2D like dimension is moving it like this, right? Only flat. It's only flat. Therefore, you cannot move it back and forth. You can't move it between, like, density. They don't have that. Now, let me explain to you what the third dimension is. Now, we are on the third dimension. In case we need a recap, I'm going to do it again. So to recap all the dimensions, the zero dimension, or the point dimension, is just done. It's not going anywhere, it's just there, right? The first dimension is a line, therefore it has distance, but it does not have the ability to move in directions. It's just distance from point A to point B. Understand? And the second dimension has distance of going, left, right, up, down in these directions, but cannot move back and forth in a 3D dimensional plane. So, a 3D object, which may sound simple, but really, it's not when you think about it. Like, 3D objects is what we are. We are essentially a 3D platform. We are a 3D area. That's what we are. Now, let's take this Game Boy, for example, right? Yes, I know I have a Game Boy. Oh my god, I'm old. And but this Game Boy, right? Notice I can do this. Notice I can catch it, mess around with it, push some buttons, turn it on, do all sorts of stuff like that, right? You can maneuver things like that. There's ways to move it. And the thing is, when you do a 3D object, there's something to notice about it. What do you see? What I see, right? I just probably just take out the cartridge. Come on, bitch. Yeah. This, minus that, this is a 3D object, meaning that, again, as discussed, I should use this example before, but a piece of paper, that's technically a 3D object, even though it appears flat by its molecular structure. It is still a 3D object, telling by the fact that we cannot touch it, nor can we have that physical touching sensation of a 2D object, because that is below a dimensional plane, meaning that we cannot touch it. A 3D object, we can touch, we can feel, we can toss around. But at the same time, if you also notice, it has a length, a width, and a height. Depending on how many geometric shapes you have, don't know. But that's also the fact that it has a length, a width is the width, and a height. And notice how it has, let's count the sides, shall we? 1, 2, 3, 4, 5, 6. It has 6 sides, right? Let's see that with something else, because we actually need more examples for this. Let's see. This metal Pokemon card, right? Got the sides. 1 here, 2, 3, 4, 5, 6. Right? That's 6 sides. So again, if you also notice about this, you can hold, as I said, you can hold it, you can do that. But there's something I didn't tell you between the other shapes that makes a 3D object a little more complex than other shapes. Basically, you have the z-axis, which, by the way, a flat dimension, the second dimension, does not have a z-axis. May I repeat that? It does not, in fact, have a z-axis. Therefore, it cannot move, essentially, back and forth. It cannot move in this direction, right? When you see this, right? A 2D dimension only sees the flat side, but a 3D dimension can see it through here. It has a bottom. It has something that holds depth, weight. It holds depth, weight. It holds like density. It holds volume. And the thing about these shapes, and what makes so much more sense to break it down like that, is because, you have to understand geometric shapes, volumes, textures, everything like that to understand what a 3D object is. And the reason I say a piece of paper is not entirely flat because it's molecular structure, making it, even though it's so visibly tiny, to the point in which technically it looks flat, but it's not. It still has density. You can still hold it. You can still, just that. Even if you were to shrink yourself, hell, even if you expand it from a molecular level, you'd still tend to be able to hold it. You'd still be able to grab it, to be able to rip it apart. You would still be able to do everything because again, it has that volume. It's a very small volume, but it has that volume, unlike a 2D object has. And to show you, hold up, we're gonna make this 2D construct happen. Have to be careful with this blades. I won't cut myself. See this? It looks flat, right? Looks flat, right? Yeah, looks flat. No, that's where you're wrong. See this? See that tiny little thing in there? See that tiny little space? That is where the volume is. Meaning that that volume has depth, has weight, has everything you need to classify it as a 3D object, even if it looks like a 2D object. Now, the next point I'm going to make, how does my explanation of basic fucking geometry and space and time and shit like that go equivalent to how the Earth is not fucking flat?
You double tap a post from last week. My careful composure starts to leak.
So, how to explain that the Earth is not flat using all those geometric terms that we learned about dimensions. We haven't got to the fourth dimension or anything that's way more complex than our human span can even comprehend right now. But basically, how I explain all that. Shapes, 3D shapes have to have depth, have to have weight, have to have height, have to have textures, have to have something that is there. And when you realize that a 2D object saying the Earth is flat, that would not make sense at all. Telling by its properties, like as described, a flat surface, even if you look at a tabletop or again as I said, a piece of paper, it's still 3D. It still has the ability to hold volume, hold depth, to hold everything like that. It's not truly flat. Saying that the Earth is flat makes no sense. Because if a 3D dimensional human tries to step or stand or breathe on a 2D dimensional plane, it would make it fundamentally flawed. It would not be able to exist at all. Because in fact, again, as I said, you can't touch it. You can only look at a truly 2D dimensional plane. There's no depth, there's no shadows, there's no light, there's nothing. It's just a 2D dimensional plane. So if you try to stand on it, it wouldn't exist to you. Therefore, it wouldn't work. Another thing about that is the Earth is flat theory would still have to be somewhat spherical just by its nature. Like for example, it would have to be like if you think about a flat surface like this, right? Just tell it. Even if you want to make the assumption that turning a flat object, like a side right here, like this, therefore turning it into only a one-dimensional construct just by turning it on its side. And not only that, but this which is standing on. So, to make that work in a 3D dimensional plane, you would have to build a dome. Which, by the way, if you notice about a sphere, well, it's not a sphere, it's a two-dimensional of a sphere. But the thing is, this is what the base would have to look like. Well, the circle, obviously, the circle part would have to be it. But the thing is, that circle would have to be the flat surface. And the dome would go all the way around 360 degrees around, therefore making a dome. Therefore, it would have to be spherical, telling by the fact that we have an ozone layer. We also have, an atmosphere. We have depth. We have the ability to again, go up. Not only go up, when you're facing a 2D dimensional surface, like this, like a side, flip this way, going up. Meaning, you flip this way, you're going back and forth. That is what we do with 3D objects. So if you were to say the Earth is truly flat, like again, like a map, it would be fundamentally flawed. And finally, we also got to get to the fact that that wouldn't even work in the first place, because again, even if it was a dome, essentially, we would have to go around it, meaning that again, the oceans, the land masses, everything like that, it would literally have to stand there around a dome, meaning that the atmosphere is like this, going from here to here. And all of that, you would have to explain how the core would work. You have to explain how the core of the whole entire planet would have to be down here. So take this metal thing again, flat side, turn outside, going up. Therefore, it has to be a 3D object. Therefore, it can't be flat. Number one. Number two, it has to be built like a sphere, telling by the fact that it's like this. It has to be built like a circle on its flat surface. It would have to go all the way up like this. It has to be, it has to be like a dome. And not only that, there's borders around the dome too. So therefore, that ocean would technically also have to be flat too. So like that, everything would be sticking up. It wouldn't be going in all directions. And finally, as we said, we have to have an atmosphere. It would have to be a closed dome. It wouldn't be truly flat. It wouldn't just be you go from one side to the opposite side, because that's not how dimensional planes work at all. There has to be a depth, a weight. It has to be texture. There has to be shadow. There has to be light shadow. There has to be something that is there to make it a 3D object. Therefore, making the Earth round. Not even round. It has to be 3D at the minimum. And all of that, if you notice that the Earth has a core, has like actual, depth to it. If you had a giant hand try to grab the Earth, it would look like this. A sphere, you cut it in half, it would look like this on its flat side. It's not actually flat, even though, like, let's just say if you cut it, like, the dome would be around here. It would basically be half a sphere at that point. But the thing is that, like, it would be here in all directions. Therefore, if you look at the side that is technically quote unquote flat, as we compare this side, it would have to, have a core. Meaning that, again, with a flat Earth, you can't have that. You can't have a magnetic pole. You can't have, and by the way, the magnetic pole doesn't just go here or here. It's not just up and down. It's in all directions of a 3D plane. Meaning that, again, as I said before, a 2D dimension only goes on a flat surface. You can't touch it, you can't feel it, you can't do anything like that. Knowing that, you can't really think of a flat Earth at all. Truly, you can't. Because that distance between those, it has to have depth, has to have volume, has to have everything that makes a 3D object a 3D object. And I guess finally, like, you would have to have something that was truly there to make it, 3D. And yeah, that about covers it. I mean, you can't really have something that is 2D. You can't touch it. You can't feel it. So depth. There's no shape. You can only see it. It's only worthy of the eye. Nothing else. Thank you for watching, and I guess in the next video I'll just probably explain how the fourth fucking dimension works. Why the fuck not? I thought it was kind of fun to make this shit up. And anyone that still believes in the flat Earth, I thought I just explained all that shit. You're stupid as fuck. Let's just say that blatantly. You're stupid as shit. You see this? You see this? This is 3D. You're dumb. You're stupid. You're a fucking idiot. After I just explained to you everything like that about how the Earth is in fact a sphere. Not a perfect sphere, a sphere with depth and volume. Thank you for watching, and yeah, this is Chaos Tomato signing off.